Solving trig equations, solving trig equations. Hey, for the next 10 minutes or so, we're going to be solving a few trig equations. Now, I'm not going to get sidetracked. I'm not going to let my ADD affect what I'm getting ready to do, but I will say mathematics is not a spectator sport. You can watch me solve these bad boys, but you really need to put your pencil down to the paper. It's kind of like when they asked George Polya, why are there so many great mathematicians coming out of Hungary? He goes, well, math is cheap, very cheap. We are very poor. All we need is pencil and paper. We can become mathematicians. You don't need any high-tech sneaker or anything like that. So what I'm going to do is kind of talk about a couple of trig equations, maybe just 3 or 4. Might produce some more videos. There's plenty of them out there. But, well, there's always an issue with solving trig equations. And part of my issue is a lot of textbooks and instructors spend a lot of time talking about inverse trigonometric functions and so forth, and then they start solving trig equations and they don't ever go back to that. And we'll talk about it in a few minutes, but let's just jump right into it. So what I have is 2 times the sine of theta plus 1 equals 0. I'm going to solve that equation. Sometimes you'll see a textbook say solve over the interval maybe 0 to 360 degrees or maybe 0 to 2 pi radians. What they're doing is they're not getting those extra rotational values, those extra solutions. But then you might see something say for all solutions. So I'm going to discuss this as we go along. But almost like solving, I hate to say a linear equation, what we're going to do is solve for theta. To do that, I'm going to subtract 1 and then divide both sides by 2. So in other words, the sine of theta is going to equal minus 1 divided by 2. Now to solve this, what we really need to do is isolate that unknown value, that theta, and what we do is we can take the arc sine of both sides. In other words, we can take the inverse sine of both sides so that the inverse sine of the sine of theta is equal to theta, and then of course whatever I do to one side I do to the other, the inverse sine of negative 1/2. Now, a lot of textbooks won't do that, which is exactly what we're supposed to be doing here. What they'll do is, and instructors will say it as well, is, well, what we need to do is think about what angle is going to give us, the sine of that angle is going to equal to negative 1/2. I mean, that's really what we're doing. So let's just do it a couple different ways. One, we could look at the unit circle. All students take calculus. So sine is negative in the 3rd and 4th quadrant. So we know our solutions are going to come here. So the question is, where does that happen? Where on the unit circle is the y value equal to negative 1/2? That's really what we're asking ourselves. So in other words, we go around the unit circle and we look at it and we go, okay, so where are my y values equal to negative 1/2? There's 1 down here. So this is actually, let's go back and do the unit circle again if you're a little rusty. It's 1, 2, 3. So this is 1/2. This is the square root of 2. This is the square root of 3 over 2. And what we end up getting is this is the square root of 3 over 2. This is square root of 2 over 2. And this is 1/2. So right here on the unit circle, there's 60, 45, and 30 degrees. So what happens is, yeah, my picture was not quite, into scale. But what happens is the sine of 30 degrees is equal to 1/2. Kind of go back to your 2 special right triangles. And the 30, 60, 90 degree triangle, the side opposite 30 will let be 1, hypotenuse 2, this is square root of 3. So the sine of 30 degrees is opposite over hypotenuse, 1/2. So that's the same thing we're getting from the unit circle. 30 degrees, there it is. But we wanted the negative value, so what we're going to do is go to these other 2 rotations that have reference angles of 30 degrees, which would be 180 plus 30, which is 210 degrees. And then the other angle in the 4th quadrant, which has a reference angle of 30, would be 330 degrees. So there are our 2 solutions to this bad boy. That's it. And these 2 values are between 0 and 360 degrees. Now, if the textbook or the question on a quiz or test for all solutions, keep in mind, not only do we get that one solution at 210 degrees, but we also get it at 210 degrees plus 360 degrees more. So 210 degrees plus 360 degrees more. And then another 360, and another 360, and another 360. Or quite possibly, instead of going that direction, we could go back this direction. Holy cow, what would that be? Going this direction would be not 210 degrees, but this direction would be negative 150 degrees. In other words, if I let k equal any integer being negative 3, negative 2, negative 1, 0, 1, 2, 3. So if k was equal to negative 1, negative 360 plus 210 would be that negative 150 degrees. If k equals 0, we have 210 degrees, which is exactly what the solution is. If k equals 1, then it would be 210 plus 360 more would give us another value that would work. This is all solutions, so we also could do the same argument for 330 degrees right there, plus 360k, where k is an integer. So, two ways to answer this, and this one actually is pretty simple. It gets a little trickier with other trigonometric ratios, but the long story short is, if we want to solve this over this interval, there's our two answers. Keep in mind, if you cheat using a calculator, it's only going to give you one of these solutions. In fact, which solution would it give you? What's the calculator going to say? Do we remember? The calculator's not going to give you either of those solutions. Bum, bum, bum! And if you understand, without me explaining it at this moment, why the calculator will not give you either of those two solutions, you have done a good job so far in trigonometry. But of course, I'm not just another pretty face. Oh my gosh, I got something up here, and here it is. Keep in mind that when we took the sine function, which was that nice little wave that went through the origin, we had to restrict its domain just like this from negative pi over 2 radians to pi over 2 radians to make it 1-to-1. So that it would pass the horizontal line test so that we could create that arc sine, that inverse sine. So the domain here for the sine function is going to be the range of the inverse. So in other words, when you type in something like inverse sine of negative 0.5 into the calculator, it's not going to give you either of these solutions. No, no, no. It's going to give you the solution for it between negative 90 and positive 90 degrees. In other words, it's going to give you negative 30 degrees, which is not a solution for this bad boy right here. It does give you the solution down here for this, but keep in mind what the calculator does. The calculator is going to give you the solution for the inverse sine of negative 1/2. The inverse sine of negative 1/2 is not the same as solving this equation along this interval, though the solution can absolutely be used to find the solution. So you have to really understand what the question is asking. So keep that in mind. Yes, negative 30 degrees will satisfy this equation. Negative 30 degrees is not in this interval. It gets a little confusing, which is why you're going to watch this video again. Let me jump to number 2. I'm not going to be able to get to many of the equations I want to because there's just so many moving parts here. But look at this one. Sine of theta times the tangent of theta equals the sine of theta. A bad algebra student would say, divide both sides by the sine of theta. I hope you have not been doing that in your classes. What I recommend you doing with this bad boy, sine of theta times the tangent of theta, subtract the sine of theta on both sides, setting it equal to 0. Setting an equation equal to 0 and being able to write the other side as a product of factors is a really great way of solving it, if you haven't figured that one out in geometry yet. Now let's factor out the sine of theta, and this gives us this right here. Distribute if you don't believe me. Sine times tangent is sine, Sine times negative, we got it. Now use the zero product property. So the sine of theta equals 0, or the tangent of theta minus 1 equals 0. We know where the sine of theta equals 0 at. That's at, let me draw that unit circle very quickly again. And here's the ordered pair 1, 0. Here's the ordered pair negative 1, 0. So sine equals 0 at 0 degrees, and again at 180 degrees. This one right here is the tangent of theta equals 1. Come on, 1 opposite over adjacent, 45, 45, 90. We should know this one. Tangent right there. This is the square root of 2 over 2, square root of 2 over 2. And what happens very quickly with this one is the tangent of 45, CSI. Who are you? Sine is y, cosine is x, tangent is sine over cosine, or in this case on the unit circle, y over x, that's 1 at 45 degrees. And also, down here, tangent is also positive at 225 degrees. And what's interesting, if we had to write these for all solutions, not just on this interval, we could clean it up a little bit better than we did on the last problem. We could probably do something like 45 degrees plus another 360, or could we just do 45 degrees plus 180? They are definitely reflections across the origin of each other, which makes the solutions a lot simpler. There's a lot of videos out there on solving trigonometric equations. I haven't even scratched the surface yet. So watch for them. Practice some of them out of your textbook. Google solving trig equations. Go to Khan Academy and listen to Saul do these. He does a better job than I do. Until next time. We're solving trig equations, trig equations.